Hello everyone, myself Sumit Maheshwari, working as an assistant professor in ABES Engineering College. Today I'm delivering a lecture on solving numericals on single phase AC system of subject Fundamental of Electrical Engineering. So we are solving two numericals today. One is here. Obtain the power factor of a two branch parallel circuit where the branch has Z1 2 plus J4 ohm and Z2 6 plus J0 ohm. So what value must be added or maybe the 6 ohm resistance to change in such that our power factor of this circuit is 0.9 lagging. So before changing our power factor, first of all, we will find out the power factor of these two branches. So we have Z1, 2 plus J4 and Z2, 6 plus J0. So what is the Z equivalent? If two Zs are connected in parallel, so we have the formula Z1 Z2 upon Z1 plus Z2. So Z1 is 2 plus J4 into 6, 2 plus J4 into 6 upon 6 plus 2, 8 plus J4. So after solving it by using calculator, we will get 2.4 plus j times of 1.8 in rectangular, and in polar form it is 3 angle 36.87 degree. So this is R equivalent, this is X equivalent of the circuit. So to find out the power factor cos phi, which is R by Z, so R equivalent by mod of Z equivalent, and this is mod of Z equivalent. So R equivalent is 2.4 and Z equivalent is 3, so which is 0.8, and the circuit nature is RL type, inductive type, so the power factor is lagging. We can also find out by using this phi. So if we will do cos of 36.87 degree, which is comes also the similar result 0.8 lagging. So in such a way, we will find out the power factor of any um, two series parallel circuit. Now we have to change the value of 6 in such a way that our power factor would be 0.9 lagging. So this is the Z1 and we are taking Z2R. So the what is the Z new? Z new again Z1 Z2 dash upon Z1 plus Z2 dash. So this is 2 plus J4 into R upon 2 plus R, the real part, plus J times of 4. So we have three terms, uh, two in numerator and one is denominator. And in Engel form, so when we are writing only angle of this Z equivalent. What is this? The angle of this. So angle of this is 63.435, and in a polar form, when we are multiplying two polar form, the angle is adding plus the angle of this R is 0 degree and minus of the angle of this denominator. So tan inverse imaginary upon real 4 upon 2 plus R. And we know that the new power factor cos phi nu would be 0.9. So what is the phi nu? Cos inverse 0.9. After solving by using calculator, we will get 25.842. So we know that this the angle 25.842 is equal to 63.435 minus tan inverse 4 by 2 plus R. So after solving, tan inverse 4 upon 2 plus R is equal to 37 point, after subtracting 63.435 minus 25.842, it is 37.593. And after solving this term, we will get the value of R, which is 5.1954 ohm. So this is the new R in corresponding to the previous 6 ohm. We are taking when 5.1954 ohm. So the power factor of this circuit would be 0.9. So in such a way, we are changing our uh, power factor improvement by using only resistive method. In subsequent lecture, in next lecture, we will discuss power factor improvement by using inductive or capacitive uh, circuit. If we have RL combination, so we are adding a capacitance in series or in parallel to improve power factor. Next numerical, if we have a coil which consume power 150 watt when operating at DC voltage. So we are making a coil R, L, and the power is DC. So it will operated at 30 volt and taking 150 watt power. So when we are operating at the circuit using DC, the inductor XL is equal to 2 pi FL and frequency of DC is 0. So XL is not counted. So the circuit having only R. So we are calculating the value of this R by using power formula. P is equal to V square upon R. The value of V is 30 volt and resistance we are calculating by dividing the power 150 watt. So by solving this, we are getting resistance 6 ohm. So in first circuit, we are calculating the resistance first. Now, when the circuit operating with AC voltage, which is again 30 volt. So we are calculating X now. So R is same. R is 6 ohm. We will find out X. So again, uh, this is the 30 volt and power is given. Power taken by this circuit is 54 watt. So when we are operating this circuit, so P is equal to I square R, and we know that the value of power 54 watt, and we know that value of resistance 6 ohm. So we will get the value of current I, which is 3 ampere. So when circuit operating at AC voltage, this current I would be 3 ampere. Now, can we calculate the voltage across resistance? VR, which is I into R. So I is 3, resistance is 6, that is 18 volt. And we know the resultant voltage, which is 30 volt. So we will find the value of VL by using under root of V resultant square minus VR square. So by using this 30 square minus 18 square, after solving, we will get VL 24 volt. So if we know that VL, which is I into XL, so the value of XL is 24 divided by current 3 ampere. So we get 8 ohm. So in such a way, we will calculate the reactance and resistance of such circuit. We have some alternative method. So the alternative method is that we know that P is equal to VI cos phi. The power consuming by AC circuit is 54 watt. Voltage is 30. Current is 3 ampere. So we will get the value of cos phi. So cos phi would be here 0.6. Now we know that the cos phi. So we will also find out by using calculator the value of sin phi. So sin phi is 0.8 in case of when cos phi is 0.8. Now what is sin phi? That is x by z. So x by z is equal to 0.8. So x is equal to 0.8 into z. And what is the z? Z is V by I, voltage operating in DC circuit, AC circuit, and the current taken by the circuit. So 0.8 into voltage 30, current is 3 ampere. So by using again, we will get the same result, 8 ohm. So in such a way, we are finding resistance and reactance of the circuit. In next few lectures, we will discuss some more numericals on resonance and other series parallel circuit. So these are our disclaimer. Thank you.